Hi friends, welcome to #TechieMit. It's a good to see you after a long time. So, uh, in response to our subscribers video, we'll see the system design principle in Java. In that, we'll see what do you mean by high cohesion and loose coupling. So, let's see by the definition one by one. So, loose coupling. So, loose coupling refers to the design code where individual components have little or no knowledge of the definition of other components. Loose coupling is something that means each component act as on its own, as if it's not aware of like any other components. So in the real world, let's yeah, consider an example of a fish that swims, and there might be several fishes that swim. So the specific fish has the knowledge to swim in his own way, regardless of he need not need the knowledge of how the other fish swim. So that's you can consider an examples of loose coupling, and in software terms you'll see what is that. So basically, loose coupling is that means loose coupling you need to when designing a program you need to consider that components should individually act as a loosely coupled. Means loosely coupled means there is no much dependency between them. So let's say there is one element A and there is one element B. So the interdependency between A and B should be much lesser within a as compared to software components if you consider them as individual components. So let's move further. High cohesion. High cohesion means that methods and data of a class or module are closely related in terms of functionality. So what does that mean? So A and B, there are there's if you consider A and B as a software models, and uh, they should be closely related in terms of functionally they should be close to each other in terms of cohesion. So there is idealism principle called as cohesion. So they should be highly cohesive in nature. Uh, so basically, it means that the degree to which a module within a class is well defined. Means a class is like it must have like a single responsibility to handle, or then it says as cohesive. That's an example, and the purpose should be clear, uh, well defined in terms of high cohesion. So that is considered as a good practice of while designing a software. So let's move further. Use case of loose coupling is scenario using interfaces to decouple service implementation. Yeah. So to as the famous example goes in the interface segregation principle also. So while designing the interfaces, they should be designed in such a way that individual interface should serve its own purpose. So it should be segregated in such a manner that instead of crumbling all the logic inside one, they should be segregated on the basis of what purpose they serve, and they should include those methods, and the class that concrete class that provide the implementation details, they will override, and they will provide implementation details to this, and they will follow the loose coupling. So for example, you can consider payment service interface with multiple implementation like PayPal, Stripe. Yeah. So yeah, payment service is one of the famous examples. So there are a lot of payment service providers like GPay is there, PayPal is there, PhonePe is there. Uh, so there are multiple service providers. So each of them have their own implementation details provided, and they have their own features implemented to provide to the end user. Like Google GPay has its own features, and they provide for the payment interaction. But the purpose is that main purpose is that it helps in doing online payments for the end user. with the help of its interface. It's designed to keep it simple, but it should provide the basic purpose of like doing online payments or like online transactions. That can be done with the help of payment service, and it's an example of loose coupling. Moving further, use case high cohesion. So yeah, so scenario utility class with focus functionality. File utils class contain only file related methods. So utility classes, while designing a software, there are very important utility classes. So file utils can contain method only file related methods. So it will specially design those methods that are only responsible for handling the file operation, like opening a file, closing a file, reading from the file, read writer classes, closing the stream, closing the or read object, all those related to file specific file handling operation exclusive handled by file utility class. And this is just an example. So utility class can be considered as an example of high cohesion. Means they have well defined purpose that, like, regardless of they are useful in the entire application. So there's like there is a logging utility. So logging utility needs to be utilized in your entire application, not in like any specific area. So you can provide logging utility class for it, where it will handle all the like this thing, like how the file is generated, what are the specifications, uh, in what format you need to see the logs, so that you can generate the utility class. And there might be some while designing complex application, there might be some applications, means some classes that contain common logic and can be implemented common logic, like there is a common network interface, there is a common database that can be accessed. But so that all like properties that might be there. So utility classes provide you can use is the high is the example, the classic example of high cohesion. So you can make use of them and get the purpose served. Moving further, so the best practices, what are that? Favor interface based design. So while designing the software, you should keep in mind that you should favor interface design, apply single responsibility principle, use dependency injector frameworks like Spring, means keeping related functionality together. So overall, the main purpose of this high cohesion and loose coupling is that it, it you should they should provide interface based design. In the solid principle, you should handle the single responsibility, interface segregation. Those are so, and dependency injection framework, which is like a classic example in Spring, in which a class itself does not create its own objects, but it depends on other classes for the creation of its own object. So like at the auto wired annotation you have, and you have construct based dependency injection, you have setter based dependency injection, you have property based dependency injection. So these are the various injection type that supported by Spring. But the point here is that they are the best practices of implementation of loose coupling and high cohesion. So this was about the theory part. Now let's move towards the practical part over here. So just to save our time, I designed the principle of loose coupling. I'll just do this part as TechieMit. So I want to demonstrate loose coupling. So yeah, to demonstrate loose coupling, we have simple idea of making use of interfaces. So consider the example we have taken here is the example of notification service, and simple is that it should send the notification, be it SMS or be it email. So SMS notification service will implement the notification service, and it will provide its own implementation of send method to sending SMS to the number, and email will send the email to that specific. It should be not mail. Email to a specific mail ID over here. You can consider writing it as mail. We have to go here as mail. Yeah. So this is the interface we taken. Method for the send. There is a to and there is a message. And yeah. And also, like, just for our implementation purpose, we are written as mail. This is message only, but we are taken as mail. So in terms of SMS, it will be a message, and in terms of email, it will be a mail. So SMS, so we are providing implementation details to this notification service. There is also notification manager, and we have done constructor-based dependency injection over here. So notification manager, we have taken notification service. You injected the notification service, that is the interface. We injected into the notification manager class, and there is a method called as notify user, and we provide the to and message. So we'll just compile and run the program. Yeah. So what is showing that? Sending email to the email ID acamit@dummy.com. This is a simple mail. Yeah. So actually these are just for the simplification purpose. We are just showing some sample test message. These are not like we are not considering any like Java's mail sending classes and all that code. We are not included, because if you try to include all those things, just uh, make the program more complex. And so we have considered only like for the demo purpose. We have segregated the SMS notification and implement notification, and that each will provide its own implementation. So upon running the program, the SMS is sent to that particular mobile number, and that email is sent to the particular email ID. Oh, that was about loose coupling. This is the output on your screen. Let's see about high cohesion. So this is a TechieMit program. Use of high cohesion. So while considering high cohesion, we are taken into consideration an employee class, and it's having its operation, its own attributes like name is there, age is there, salary is there. Yeah. And this a provided constructor and just a segregated methods are there. Simple. And this is the classes, and there is an employee repository. The employee repository, what is contained? It contains a public constructor to initialize the list, and there is a method called as getEmployees. Okay, get all employees. So all employees are, these are like names you have created. We are in name, age, and the salary part. So 4 employees we have considered, and that get filter employees. So filter employees, for example, you consider filter them on the basis of salary. Those employees whose salary is greater than or equal to 50,000, those will be added over here and filter, and we will collect them into the list. And after that, we have taken the average salary of all the employees, and we will display the average salary. So now we'll take one more consider example into consideration. Provide list of all employees in highest order, descending order. We'll consider. Okay. So we'll write a method accordingly. Public list employee get emp salary emp list. Okay, so we don't have to filter anything. This will be Yeah, so just a double something. This order will make map product map, because will the map function, it will map according to each and every salary. So we'll take we'll use a method reference and we'll take the get employee salary. Okay, so that will sorted will come. Yeah, collections reverse order to best. There is some error over here. Map will consider a sorted function. Right there. Collect collectors list. Yeah, because this is a double function and it should return the list in all the salaries in with the double data type, and we are sorted in the reverse order and we are collected in the list. Now here what we'll do, we'll print the statement list of employees in descending order salaries. So service dot for each system out from Brandon. This is the method. So we are listing all the employees. We have listed of the employees getting above 50,000 salary, and we have taken the average of all the salaries. So that we have taken the average ones, and we have to map to double over here. No, there is the average. It will take the average of n number of salaries. So just we use the map to double, taking the average. Array here we will use orange dot get 0 by this default value. If we are not able to get any value for the salary, we'll try to compile around the program. Yeah, so if you see this program now, see, it's showing the list of all employee in ABC company is Jack David, his age, salary, Neha Sharma is her age, is her salary, Ravi Verma, his age, his salary, John Carlson, his age, his salary. So these are all this data in the get all employee list. After that, we have filtered on the basis of salary, only those salaries which are above 50,000 it will get. So correctly it's printing. It has included the employee with 29,000 salary, so it is printing 85,000, 72,000, 1,34,000. So it is printing all the employees. Yeah. So this is correctly doing correct for two list. And after that, average of is taken. It has a stream dot. After that, average of all these salaries comes to 80,000. Uh, After that, we have printed all the employees in the descending order salaries. So starting with the highest salary first, so it will print the topmost salary. After then follow the third below order, then the next order, and the lowest salary will print in the last. As it said, the descending order. We can also print in the ascending order. Directly you have to include the sorted, and it will print in the ascending order, but you include in the descending order that is currently printing. Highest salary keeps showing at the top. And this was the example of high cohesion, in which, yeah, the important point is that, see, there is employee class we are taken into consideration, and the attributes we are taking into consideration is name, age, and salary, and we can do any kind of operations basing on like these employee attributes. So we can filter the according to salary, we can filter according to the age, we can filter according to the like we can take the average of the salary. Means a lot of operations can be done, but it's high cohesion means it's depicting high cohesion, and if you consider this as a module, so collectively they are holding high responsibility. Means the single class is responsible for handling all the operations of the employee. So it's for it's like you can consider comprehensive logic it holds then itself. So this example was all about to demonstrate the high cohesion and loose coupling in the design principle in Java. So do keep liking, subscribing to #TechieMit. More to come on design principle and design pattern. See you then. Bye for now.